Hello students, welcome to the first video of the module 5, that is joint probability distribution. In this video I am going to give the introduction of what is joint probability distribution. The joint probability distribution and the joint probability. If x and y are two discrete random variables, we define the joint probability function of x and y by p of x is equal to x and y is equal to y, that is given by f of xy, where it satisfies, this f of xy satisfies the conditions f of xy is greater or equals to 0 and double summation of f of xy is equals to 1 for x and y. The joint probability table. So here the x1, x2, x3, etc., xm and y1, y2, y3, yn, the sum of these values will be f of x1, f of x2, f of xm, and whose total, if you take column wise, it is going to be equals to 1. Similarly, row wise, if you take, that is the column totals, if we take, that is g of y1, g of y2, etc., will be also equals to 1. So when we take x1 against y1 like a Cartesian product, it is j11, and x1 and y2 if we take, it is j12, x1 and yn if we take, it is j1n. Similarly, x2 and y1 if we take, it is j21, j22 and j2n, and whose sum will be f of x2 and so on. So if we take xm and y1, it will be jm1, jm2 and jmn, whose sum will be f of xm. So the sum of j11, j21, etc., jm1 will be g of y1, and j12, j22, jm2 will be equals to g of y2, and j1n, j2n, jmn will be g of yn, whose total is again equals to 1. This is the joint probability distribution table. So coming to the marginal probability distribution, when we take f of x1, it is nothing but the sum of j11 plus j12 plus j1n, whereas g of y1 if you take, it is j11 plus j21 plus m1, and f of x2 is j21 plus j22 plus j2n, and g of y2 is j12 plus j22 plus jm2, and f of xm is jm1 plus jm2 plus jmn, and g of yn is j1n plus j2n plus jmn. Next, f of x1, f of x2, f of xm, and g of y1, g of y2, g of yn are called as the marginal probability distributions of x and y respectively. Now, what are the things we are going to learn in this video is the expectation, variance and the covariance. If x is a discrete random variable taking the values x1, x2, etc., xn having the probability function f of x, then the expectation of x denoted by e of x or mu x is defined as the relation e of x is equal to summation xi into f of xi. This is the expectation which will be denoted by e of x or mu x. The variance of x is denoted by v of x. It is defined by the relation v of x is equal to summation I equal to 1 to n xi minus mu the whole square into f of xi, where e of xi is given by summation xi yj into jij. If x and y are the random variables having mu x and mu y respectively, then the covariance of x and y denoted by COV or covariance of x, y, and it is defined by the relation covariance of xy is equal to e of xy minus mu x mu y, and Next is the correlation of x and y, and it is denoted by rho of xy, and it is defined by rho of xy, or the correlation of xy is given by covariance of xy divided by sigma x into sigma y. Note, if x and y are independent random variables, then E of xy is equal to E of x into E of y, and covariance of xy will be 0, and hence the correlation is also equal to 0, provided the both of x and y are independent random variables. Let's see the examples. The joint probability distribution of two random variables x and y is as follows. X takes the values -4 to 7, y takes the values 1, 5, and 1 by 8, 1 by 4, 1 by 8, 1 by 4, 1 by 8, 1 by 8, whose total will be 1 again. Compute the following. First one, E of x and E of y. Second one, E of xy. C, sigma x and sigma y. D, covariance of xy and correlation of xy. These are the things we need to determine. The distribution or the marginal distribution of x and y is as follows. This distribution is obtained by adding all the respective row entries and also the respective column entries. Now let's see the distribution of x. So the distribution of x is given by 1 and 5. So the total of that will be half and half. That is f of xi is half, and for 5 also it was half. We can refer here how it has come. I'll just show you. See this. 1 by 8 plus 1 by 4 plus 1 by 8. When we take the total, it will be 1 by 4 plus 1 by 4, which will be half. Similarly, 1 by 4 plus 1 by 8 plus 1 by 8 will also be half. And when it comes to 1 by 8, that is column wise, if we add, then for y it is 1 by 8 and 1 by 4 will be 3 by 8, and 1 by 4 and 1 by 8 again it is 3 by 8. So likewise we can give the table. You can refer here. So this is the tables which we have done. So 3 by 8, 3 by 8 and 1 by 4. Now let us compute E of xy, E of x, that is xi into f of xi, which is 1 into half, which is taken from here. So this 1 and this half, when we multiply, again 5 and half from this. So when we take total, it will be equals to 3. Similarly, for E of y, it is -4 into 3 by 8, 2 into 3 by 8, 7 into 1 by 4. When we total it, it will be equals to 1. Therefore, E of x or mu x is given by 3, and mu y or E of y is given by equals to 1. Next, E of xy. It's given by xi yj into jij. That is 1 into -4 into 1 by 8 plus 1 into 2 into 1 by 4 plus 1 into 7 into 1 by 8 plus 5 into -4 into 1 by 4 plus 5 into 2 into 1 by 8 plus 5 into 7 into 1 by 8. That gives us on total 3 by 2. That is E of xy is equals to 3 by 2. We have calculated E of xy. Now sigma x square. What is the formula for sigma x square is E of x square minus mu x square, and sigma y square is given by E of y square minus mu y square. Let us compute what is E of x square. That is sigma xi square into f of xi. That is 1 square into half plus 5 square into half. That is 13. Next, E of y square is yj square into g of yj. That is y square, that is 4 square, that is 16 into g of yj, that is 3 by 8. And 2 square, that is 4 into 3 by 8 plus 7 square, that is 49 into 1 by 4, which will be 79 by 4. Next, sigma x square is given by e of x squared minus mu x square. Therefore, 13 minus 3 square, which gives us 4, and sigma y square is equals to 79 by 4 minus 1 square, which is 75 by 4. So sigma x square is 4 and sigma y square is 75 by 4, and hence the root of which, that is sigma x is 2 and sigma y is 4.33. Next is the covariance and the correlation. The covariance is given by covariance of xy is e of xy minus mu x mu y, which we have already computed, just we need to substitute. So e of xy was 3 by 2 and mu x and mu y was 3 and 1 respectively. On substitution and simplification, we get minus of 3 by 2. Hence the covariance of xy is minus of 3 by 2. And the correlation of xy is given by covariance of xy divided by sigma x into sigma y. So the correlation just now we have determined, that is minus 3 by 2 divided by sigma x was 2 and sigma y was root of 75 by 4, which on simplification minus 3 divided by 2 root of 75, that is minus 0.1732. So we have already calculated e of x, e of y, sigma x, sigma y, covariance of xy and correlation of xy. With this, we have done all the type of evaluation. Thank you.